You're listening to Don't Waste Water.
And this podcast is brought to you by Simple Lab.
In 2017, even earlier than 2018, we're at the final day of signing a deal to sell the business. At the time, one of our core technologies, one of our patents was pending, and we had worked through due diligence months and months and months. We get all the way to the point of the right guy at this company to sign off on the deal. And he says, I don't think the patent's going to grant. Sorry, we're not moving ahead. The day that we're signing the deal to sell.
Hello, bonjour, and welcome to the Don't Waste Water podcast.
I had scaled tech. I had been in every role. The number of nights that I've slept in my truck in the field in the Permian is many, doing field installations, field operations, collecting data and running testing.
I'm your host, Antoine Walter, and in today's episode, I'm delighted to welcome Jay Keener as my guest.
I haven't yet found a brine where we don't believe we're going to be the most efficient way to concentrate and purify after that. I don't see a pathway today for another company to implement liquid extraction at the level of cost efficiency that we can.
Jay is co-founder and CEO of Altillion.
As a philosophy in business and in life, I genuinely believe that almost every company has the potential to collaborate with almost every other company. We're collaborators before competitors, and we'd love to work with everyone.
Altillion is a value-driven innovator delivering scalable mineral extraction from brine. Would you imagine your CEO in a hard hat and muddy boots, troubleshooting a filtration skid at 2 a.m.? Would you expect him by sunrise to be logging field data, negotiating a new partnership, and finalizing a grant application, while before noon rolls around, he's on a Zoom call with potential investors? Well, I guess there's a name for that. That's startup life in Watertech, where wearing many hats is not just a catchy phrase, it's the way to go. I could circle back to books, as I would do in a Books Club episode, and tell you that in the lean startup, Eric Ries famously argues that constant iteration and pivoting fast are the only ways to stay alive in a hyper-competitive market. But reality outpaces theory, and you may well know that Watertech has that turned up to 11. Our sector is capital-intensive, highly framed by regulatory landscapes, and everybody wants to pilot everything while being first to be second. But what could be a burden is also a blessing if you have what it takes to strive in that environment. And it certainly starts with agility. As a startup, you have to be ready to flip your entire approach in 6 months. Jay will give us an example of that in just a minute, but it's a pattern across most of the successful entrepreneurs we've heard on this podcast. These moves that would be unthinkable for traditional incumbents are your superpower in early stages. You experiment, adapt, or fail. But agility is not enough. You also have to be ready to not walk alone and find allies all around the water board. What I could somewhat coin partner or perish. I can tell you I've seen incredible companies with great IP struggle and fail, and incredible entrepreneurs with okay-ish technology succeed because they teamed up with the right people in the right places. As Jay will also demonstrate today, forging alliances often matters more than walling off your technology. We're watching competitors morph into collaborators, co-developing new processes, or even setting up shared pilots and projects. And why not? Rivals often tackle the same fundamental challenges. That's how your ecosystem building, not just empire building. Let me name drop another book here. Geoffrey Moore's Crossing the Chasm reminds us that until a new technology truly crosses over into mainstream adoption, you need as many allies as you can get. Now, those are not the only water entrepreneurship tips you'll get today, as Jay will also share how to successfully spin out from a larger corporation, how to fast-track your learning curve as a young professional, and how to turn a hard wall into an opportunity. And I could try to look clever here by mentioning a third book with Ryan Holiday's The Obstacle is the Way, but instead, I leave Jay the floor right after reminding you that if you like what you hear, I'd love for you to take this episode and share it with a friend, a colleague, your boss, or your team, and I'll meet you on the other side. Hi Jay, welcome to the show.
Thanks for having me.
Let me go into maybe the hottest take, which is that your process looks like solvent extraction, yet you explain how it's not and has different merits. Can you give us the very short elevator pitch as to why it's different and probably better?
Yeah, absolutely. You're right that we actually avoid calling our process solvent extraction. Solvent is almost the unspoken word in Altillion's office. And really, this comes down to two things. Number one is solvent extraction inherently instigates a feeling of chemistry losses downstream of the process. We have virtually no losses of chemistry coming out of our process. It's a key cornerstone of why we're different. The ability to recover and reuse the organic liquids in our process is a key cornerstone. We're careful not to instigate that negative preconception that most people have. The other is that solvent extraction typically applies blends of liquids in ways that create process challenges, cost challenges, and also health and safety challenges. We have a lot of flexibility in our process in the way that we apply chemistry, and we mitigate many of those requirements. We are liquid extraction. Besides two liquids that don't mix, touching each other for an extraction to occur, almost everything else is different.
Let me be the contrarian here, because I've talked with solvent extraction companies and none ever said to me, we are losing solvent. You're just one more who says you're not losing solvent. What's the secret? What makes you so confident that you're not losing any?
The key for us is, solvent extraction. You're taking an organic based extraction liquid and blending that in with your aqueous phase liquid. And that organic liquid is extracting the target metal or constituent from the aqueous phase into the organic, right? What happens after that extraction has occurred? Now you have an organic with your target constituent, but you need to separate that organic from the aqueous phase. And how is that done? Typically by everyone in the industry today is gravity-based separation. Either it's a traditional mixer settler or some more exotic type of gravity-based separation. We have a proprietary secondary organic recovery step in our process, which is a system that removes organics from brine or from an aqueous phase in a way where we're not using a consumable and we're not impacting the integrity of the organic that we're recovering, but ensures that we recover virtually all of the organic, regardless of concentration and regardless of whether it's dispersed, emulsified, or even dissolved. We have essentially an absolute filter on the back end that ensures we always recover the organic.
Can you explain how it works, or is it really a black box and rocket science, which you don't want to disclose?
I'd love to explain it. So there is an interesting category of technologies that are absorbent and regenerable. Much of my career and some of our other co-founders in the company's career have been spent around this category of water filtration technologies. Each of the technologies on the market that are absorbents and regenerable have different functionality, different composition, different ways that they're regenerated, and different organics to which they have the highest efficiency operation. We have a regenerable organic absorbent system that is highly efficient at recovering the types of organics that we're using from an aqueous phase and enabling recovery of those organics back from this absorbent repeatedly without impacting the integrity of the absorbent. We have a significant portfolio of patents around this material and the process for regenerating.
So let me try to make my mental picture here. In conventional DLE, you have this medium which you put with the brine, which is gonna mildly concentrate the lithium, and then you try to recover that by washing it back with water, washing it back with acid, and then you go to the more complex flow sheet, which you're aiming at simplifying. If I get you right, you're using an adsorbent, probably not the same, but instead of putting it in the front, you put it in the back. So you have the solvents doing its job in the front, or the chemical or the organic, not to call it a solvent, catching it. And so you just have the organic together with lithium, and your adsorbent is not scattered at catching the lithium, it's scattered at catching the organic. And as it catches the organic, well, the other part is the lithium, and so you can get it out. And I'm saying lithium here, but it could be a different mineral in the future.
Absolutely. Right? And you've hit a key point there. It's not specific to lithium. Our technology is the implementation process. So we've talked about the organic recovery. On the front end, we have proprietary systems for injection and mixing of organic in solution. When you combine these systems into our integrated process, Altillion's technology doesn't hinge on material science for a lithium organic extractant. Our technology is the implementation process for implementing organics to do extraction. And so we can change the organic for other lithium extractants, for other lithium applications, or we can change the organic to go after entirely different metals.
We'll go into what you need as a request and what would be like this pre-treatment needs or not, and how the full flow sheet builds. We'll keep that for later. We go to that. Just a curiosity question, because the other thing you hear when it's solvent extraction, it's usually one is the leakage of the solvent, which you explain how you solve that. The other is if you use kerosene, it works. But if we want to get rid of kerosene when it's for flying aircrafts, we maybe don't want to use it as a solvent extractor. So is it something you're using as well, or do you have a different approach there?
We do not have to use kerosene.
Okay. It's just the two solvent muggle questions, which I usually have. So you got that out of the way. Before we go into the depth, you mentioned a bit of your past. I actually looked it up, and that's where I'd like to get the full story, because you have a specific profile. You're a repeat entrepreneur with successful exits. And already that puts you in a specific cluster. There's not so many entrepreneurs in water and lithium endeavors who have already gone through a cycle. But you were not starting from an entrepreneurial journey. You started working for a company. And I'm wondering what happens in 2016, which makes you go to your own adventure and say, I want to build my own thing.
Yeah, it is a good question. It's always amazing for me to think back through my career journey and trajectory. You're right. I did start working for a company. Actually, the first company I started working for, I started while I was still in school getting a chemistry degree. That company itself was a startup started by one of my chemistry professors. And so the first job I had was employee number 3 or 4 of this startup water treatment company, commercializing a technology for doing advanced filtration for industrial wastewater. My passion for water started as a kid doing mission work, like going and doing developing country water related things. So I always knew I wanted to be in water. My first job dumped me right into the startup environment. There's something about a startup environment that definitely takes a certain personality. There's absolutely nothing like it. The amount you learn when you're forced to wear many hats and deal with that dynamic environment, it's just incredible. And so for me, as I worked through that first job, I was able to experience many different milestones and startup phases. I wasn't driving as an entrepreneur, but I was fortunate to be employed there and to have the opportunity to experience. And so it was that initial starting of a company, the initial team building, the initial fundraising, getting the first venture capital investment, the first acquisition, even though we were small, and even to the point where that moved me overseas for a small stint overseas. Through all of that, what I experienced was early stage technology. How are you scaling this from the lab? How are you building a business around this? Within that, one of my roles was interacting with many peer technology companies in the industry to see where are the synergies, where are the collaborations, who could we try to acquire, who could try to acquire us? How do we piece all these things together? By the time I reached 2015, 16, I think I had gone through this period of immense learning and hands-on experience around all these different facets of what a startup company around water looked like. And then a little bit of right place at the right time. A little bit of luck is always a part of starting a business. And I happened to have the right knowledge and experience base with the right potential partners and the right market focus. It really became kind of a no-brainer to get a business started at that time.
Sorry to interrupt Jay and this conversation flow, but I wanted to quickly thank my sponsor, Simple Lab. If you're in the water industry and you're running a water quality sampling campaign or tweaking plant process performance, Simple Lab has you covered. You can easily order online from over 275 commercial labs. Simply put, Simple Lab is a one-stop shop for everything from routine testing kits to specialized analyses like PFAS or microplastics. You don't have to juggle multiple labs and complicated logistics anymore. Instead, you get a single, streamlined process for ordering kits and reviewing results. Plus, there's always a real person to talk to, so if you're tired of cobbling together lab documents and quotes and services for each new requirement, or you just want to try a new way for more efficient testing of water samples, check out Simple Lab. They're all about making water quality testing, well, Simple. So head to their website, the link is in the description, line up the tests you need, hit order, and let them handle the rest. Thanks Simple Lab for supporting my work. Check them out to support me, and back to me. So you were in the startup car somewhat, but not at the steering wheel. And then in 2016, the stars align and you say, okay, I want to have my shot at the steering wheel. And hence you go with Xedia Process Solutions, which I might be pronouncing terribly.
Xedia Process Solutions.
I have that debate all the time with asylum guys who tell me I'm pronouncing the name of the company wrong. Sorry, if it starts with an X, I have no clue how to say it.
Okay. We didn't either, I don't think.
What was the purpose of that company, and what leads you on a pretty short journey towards the exit in 2018, and then you stayed along for 18 more months, right?
Yes. So really, for me, a lot of my businesses that I've started or been involved in have started not from me sitting at my desk with a whiteboard saying, I want to be an entrepreneur, I want to start a company, what should I do? They usually start with interacting with the industry, interacting with my network, and just paying attention to where are their pain points, what are people really focused on, what are challenges that need solving. Xedia came out of, at the time, another colleague and I were doing quite a bit of consulting work for different parties in the industry. Sometimes when you're doing that kind of work, you come across technologies or companies or partners where it's just very clear this needs to be a business because the problem that it's solving, the need for the market, it's just very clear. And we can do a lot more with this if we actually build this into something. And so Xedia really came about like that. In interacting with a partner in industry, they had some interesting tech. A colleague and I were exploring some interesting tech. The industry had a clear need. And we formed Xedia as a 50-50 joint venture between my colleague and I's consulting business and this other company that at the time was a small specialty chemicals company. It was really about trying to take 1 + 1 to turn it into 3, 4, or 5 for the industry in a way that we could scale technology for their problems much faster.
What was the problem you were aiming at?
So that problem was primarily focused on oil field brines. Today, we talk a lot about mining brines and lithium. Most of my background is brine focused from other areas of the energy industry, like oil and gas produced water. And in oil and gas produced water, one of the primary issues with dealing with produced water is residual oil removal from the water to meet your environmental discharge requirement or to meet some type of reuse requirement. And so we were developing advanced filtration systems to remove that residual oil. The big problem was costs were extremely high, uses of consumables were extremely high, and sometimes performance was lacking. We were developing technologies that could lower cost and hit spec.
Which is the first dot you connect to some of my past guests. I was discussing the Permian Basin with Carbonet on the microphone some weeks ago. I noticed that on your path and like, oh, interesting. How does the story go to an exit in 2018? And what did you learn from that process?
As always, when you're in these early stage businesses, you set a plan, you have a trajectory, you look at where you're going, you have ideas about what you want to do, but ultimately customers and market really drive direction for where you can take what you're trying to do. We had really hit a crossroads in the business from a standpoint of who are we going to be when we grow up? That was, are we going to continue to focus on only these filtration and technology solutions that we've been developing, or will we expand the business into more recurring revenue kinds of businesses, services, and things like that? We were really looking at a couple of different pathways forward. The story of Xedia is an interesting one because we actually, in 2017, even earlier than 2018, were at the final day of signing a deal to sell the business to a subsidiary of a very large multinational industrial water treatment company. At the time, one of our core technologies, one of our patents was pending, and we had worked through due diligence months and months and months. And at the time, I was our COO, but I was also essentially our CFO. I was managing our budget and all of our financial models. And so we're just working through this. We get all the way to the point of the right guy at this company to sign off on the deal. And he says, I don't think the patent's going to grant. sorry, we're not moving ahead. The day that we're signing the deal to sell. So that deal fell apart 2017. The patent, of course, was granted 4 months later. So patent was granted. At that point, it would have really stuck us into, we are this technology provider. We've sold the business early. Obviously, when you sell the business early, many of your listeners will know there's a lot of commercial terms that come around that with earnouts and all kinds of things. But that gave us a pathway to really relook at, are we sticking with this business model? Do we want to expand into services? And ultimately, we did expand into services. And we went from focusing on international filtration projects. We were doing offshore Indonesia, South America, Colombia, Middle East, India. We were all international in our water filtration projects. And within 6 months, we were probably 90% focused in the Permian. It was all around water treatment service. It was all about reusing and recycling brines. And that really led to the exit pathway for Xedia to sell in 2018. That exit was a bit unique, essentially sold to a private equity group that turned that into a roll up into us co-founding Blackbuck with them. But it was that pivot to onshore US services, much more rapid project cycles, much more recurring revenue type things that drove to an exit in a way that we wouldn't have achieved had the earlier exit gone through.
If I try to do a schematic of that, your initial business was a very specialized piece of the full treatment train, but that specialized piece could go to all places worldwide. So the market was super horizontal, but you had a very small section, and you went to something a bit more vertical where you're offering more around, and now you're dedicating to a very specific geography because a service business probably requires you to be on site, and it's a bit harder to be on site in Indonesia than it might be in the Permian Basin, at least if you're based where you're based. So, and that allows you to basically within 6 months, which is crazy fast, to not turn the company on its head, but do kind of a soft pivot, if I get you right.
Yes.
What gets you bored 18 months later?
I would say bored isn't a fair description. There was some divergence in the team. So I moved on to work on other projects.
Talking of those other projects, your next big one to me is KDH trading. The reason why it's intriguing to me is you accelerate and incubate technologies. That in itself is intriguing. The other thing is I found out companies there, which I had no clue had worked with you. Oxford Flow, Swirltex, which were on that podcast at some point. What's the story of KDH trading and how do you accelerate those guys?
So really post Blackbuck, interesting time. I went into semi-retirement for a few months as I figured out what the path forward looks like. And right after that time, COVID hits March, April 2020. And it was a natural time for me to step back and move back into the startup early stage water technology roots that I had come from. The way I manifested that initially was going back to smaller early stage companies that needed some additional pieces of the puzzle to get their scale up, field implementation and market penetration, executing the way that they hoped it would. A lot of the value proposition that I felt I was bringing to these companies was I had scaled tech. I had been in every role. The number of nights that I've slept in my truck in the field in the Permian is many. Doing field installations, field operations, collecting data and running testing. When you've gone through all of those experiences, there's a lot that you can lend into others that are trying to grow tech and trying to grow their business and penetrate markets.
Let me just cut you here because I think that's an overlooked gem. You were the CEO/CFO of the company and you were sleeping in your truck to ensure that it's installed right. That is really the disconnect when the financial people don't understand the technical people and the technical people don't understand the financial people. So if you're doing those extra steps to be there and do it, you're solving the disconnect. I just wanted to highlight that is gold.
I appreciate that. And I do think it's critical, as both the, chief operating officer, like you said, but also kind of the CFO level person at the time. But I also for much of those years, I was the field operator or the field installer. I was one of the people on the team doing installations and operations. And when you have that sense of what works and what doesn't work, how you collect data, how you don't collect data, what a Permian winter looks like, how you have to prepare for that, all of these things. And in particular around oil field and energy, the space that I was coming from, it definitely is valuable. And I would venture to say almost unique in aspects of many founders that are early in businesses. And I think that perspective helps a lot. And I wanted to bring that to other small businesses in ways where I could help them accelerate. Therein lies the acceleration side of KDH, right? Let us be a bolt-on accelerant to your business, hitting all the facets from strategy to commercial, sales and marketing, to operations and implementation, to piloting. We wanted to be this bolt-on accelerator. I really had the privilege of starting that in the early days of COVID, and then bringing on additional team members, serving as an acceleration partner for some really interesting companies. Two of which you just named, Watertech and Oxford Flow.
There's actually one more in the list, which got me curious because you have in the list of companies you accelerated through KDH, a company called Altillion. What's the story there? Is it like it was already somewhat existing and you brought it to real life and then you jumped on, or is it because you started as an idea within that ecosystem and then thought that's too big of an idea to just stay within an incubator? What's the story?
Altillion is not one of the technologies that we have incubated internally within KDH. I would put Altillion in that acceleration side of KDH. The way Altillion was formed is interesting in that Altillion was not a garage-based startup. Hey, we want to do liquid extraction better. The technology under Altillion was incubated within an existing process technology company based in Houston that's almost 20 years old and has a track record of commercializing technology for process separations and applications. Some of their technology was around very efficient ways to recover organics from brine. Some of their technology was around very efficient ways to mix organics with brine. And so really within their own incubation of how do we evolve these into new solutions, into new applications, their team, and in particular, the CTO at Altillion, whose name is Caleb Smathers, was developing and incubating these ideas and was serving as a partner to them in the very early days of their incubation, running small laboratory testing. KDH, one of the strengths of our team is we have an immense global network of stakeholders, whether that's asset owners, operators, or technology companies or energy companies. KDH was helping them source different brines with lithium that they could run their incubation lab-based testing on. It sort of became a strategy participation, and it really started to expand over some time to the point where the owners and board of that company came alongside the KDH team and said, we've incubated this idea. We've proven that it has some legs. And through some strategic discussion, we decided that we would co-found Altillion as a new business and we would spin the tech out into Altillion and really truly run through the commercialization process of the technology. And so that's really how the founding team of Altillion came together. We were a bit unique in many of the lithium-based startup companies in that the foundational cornerstones of our technology are already commercially proven, which gives us a leg up in terms of de-risking scale up.
There's a lot to unpack here. The spin out type of thing is something I discussed, for instance, with Water, with 2V, the company, which is also a spin out of the same type. It sounds to me like I should go to Texas to try to understand what those groups are doing and why they spin out great ideas like that and don't keep them internally, because I would keep the gems for me, but that's me.
we would love to have you. Come visit our shop and we'll chat about it.
The other thing which surprises me is that if you're based in Texas and you're doing a lithium type of play with proven commercial stuff, why don't you start with oil-filled brines? That's the obvious. And I get that you can be doing the full palette of brines, but it sounds to me like produced water comes in priority 3, priority 4. Why don't you start with what's just in front of your door, and why do you go for something else?
The easy answer is we did start with produced water. And produced water is still a major part of Altillion's strategy. I would venture to say produced water is almost in our blood, right? As you can understand from our background. Altillion started as a DLE company focused on the DLE step of the flow sheet. The reason for that is our process is so efficient at extracting lithium that we were extracting 20, 22 ppm lithium brines from our oil field partners, and we were recovering all of the lithium down to 3 or 4 ppm. What we found through our testing is, regardless of the starting lithium concentration, we can recover all of the lithium down to a residual 3, 4, 5 ppm. If you start at 20 ppm, we'll recover 75, 80% of it. If you start at 2000 ppm, we'll recover 99 point something percent of it. So the natural focus was oil field brines. We have the customers, it's in our backyard. We know the space, we know the brine. What we learned is that our technology is extremely efficient at extracting the lithium, and it inherently highly concentrates and purifies the lithium. But where other DLE technologies shine versus ours, and at least in terms of the organic chemistries we use today, is that those technologies are good at isolating lithium from calcium and magnesium. As we started working through these applications, this was right around the time I would say lithium prices are falling. I wouldn't say that energy companies had completely lost their excitement about lithium, but certainly project economics around 20, 25, 30 ppm brines were becoming a little bit different than they were when prices were at, $60, $70, $80 a kilogram. And so between that focus on the low concentration brines in the market sort of shifting, and also us really realizing through our testing our true value proposition, we started focusing on brines where our upstream technology partners, the other DLE companies, really were having the shortest path towards commercial opportunity and commercial success. And so we're still very much working on oil field brines and doing interesting things in oil field brines. But because we're no longer just focus on the DLE step, because now we're post DLE processing, the rest of the brines have really opened up wide for us. And it's all about shortest path to commercial implementation.
That makes a ton of sense. Basically, if you go with the 60s patented dope process where you put your adsorbent, it's very mildly concentrate the lithium, but it isolates it, then you would be the best mousetrap to get from that to the actual 99 point something pure lithium. Whereas if you put it in the early stage, 70 to 75 is not ridiculous. An evaporation pond is maybe 30 or 35% effective, so you would be already double that. But it's not as impressive like the one where you have to go like 3 times below the comma to find where you're not at the absolute top.
Well, I will say on that, if you put us as the first DLE step, we will maintain that very high extraction and recovery efficiency. If it's 100 ppm, we'll extract it down to 3 or 4 ppm. So you have 94, 95, 96% recovery. Yeah.
I was going to ask exactly that, because you have those two processes. You have Lycon and Limex. If I understand you right, you're still offering to the market the Limex solution where the DLE step doesn't really exist and you're a one-stop shop.
It's really the way we think about that. Limex in reality is kind of the unicorn. Right? Do you have a brine that already has divalents at such a low ratio, or divalents have already been removed so efficiently that we can do our extraction and concentration? Limex and Lycon are essentially the same process. How are we implementing it, and how many stages, all the nuances of how you design your process for a given application we would consider. But our extraction and recovery of the lithium really looks the same between Limex and Lycon. The idea of having a distinction between the two names was to indicate to people that our recovery of lithium doesn't depend on concentration, and it doesn't depend on having anything specific upstream of us. It really depends on having divalents gone. That's why we love now that we're collaborating very closely with other DLE companies, because the synergy of our technologies is so great. And so many brines, DLEs look like they may be the most efficient way to remove divalents. And I haven't yet found a brine where we don't believe we're going to be the most efficient way to concentrate and purify after that.
That is an interesting segue. You're partnering with DLE companies. That is something which surprised me. I noticed that you signed a agreement with Evolve. The last time I visited Evolve, they had an end-to-end solution, and they made clear that it's not really what they want to commercialize. It's what they had to build for the sake of piloting. I know it's not really part of their strategy to be an end-to-end, but still, if I look at what they're doing today and what you're offering, I could see how you would be somewhat competitors as of now. What gets you, instead of competing, to partner?
I think the first is, in general, as a philosophy in business and in life, I genuinely believe that almost every company has the potential to collaborate with almost every other company. My initial instinct always is to seek collaboration versus direct competition. Obviously, every business will have competitors. You'll always compete for revenue. There's no inherent way in business to not compete. But when you're in this type of nascent industry and you're dealing with this broad range of early stage technologies, we have a long way to go to see which technologies are going to play out, who's going to win. I think, when you had Adionics on your podcast, you talked about 60 plus DLE companies. We've heard some people quote 80 plus DLE companies now. Maybe it'll get down to 3 to 10. Over time, the most efficient technologies and flow sheets will win out. You don't even have to be the technology chosen on the first plants that come online in 2027 or 2028 to be the one that will win out. We want to aim to collaborate with as many other technology players in the space as we can. We want to help drive that flow sheet simplification, that most efficient flow sheet, that lowest cost solution, because the lowest cost solutions are going to win, especially as we look at lithium prices for the next couple of years.
That is an interesting one because my brain agrees with you. Now my eyes see otherwise.
What do your eyes see?
I was in South America end of last year, and I've spent some time on the Eramet DLE plant in Argentina. So the one which arguably is the first in the world to have an end-to-end DLE process where it starts with a brine, it ends with a battery-grade lithium. And what surprised me the most there is the complexity of the flow sheet. Like really, it is a quite complex process with lots of steps and lots of moving parts. Mm-hmm. And I didn't have that conversation with Eramet, but I had it with Vulcan. And I had roughly the same conversation because they have roughly the same flow sheets. And I asked Vulcan why they would go for what sounds to be a complex flow sheet. And the answer they gave me is what looks like a complex water project is actually a very simple mining/oil and gas project. Meaning that what looks to me as a complex flow sheet, if you compare it to a petrochemical refinery, is pretty easy. So who wants to simplify that? As elegant as simplifying the flow sheet message is, how does it stick with people who see complexity as their second nature?
Yeah, it's a great question. And I think your point is spot on. When you look at refineries or petrochemical plants or an offshore platform in the energy industry, complexity is integrated and operated for decades. I don't see complex flow sheets or what would be perceived to be a complex water flow sheet as being the limiting factor. I don't see complexity as being the reason why people don't want to implement these flow sheets. Simplifying flow sheets is a simpler way of saying driving down costs. If you can remove process steps that are high CapEx and high energy or high OpEx, it's really about driving down costs. It's about driving down financing hurdles for projects. A lot of lithium triangle projects will be done by mining companies that have large balance sheets and can finance their own projects. Outside of that, many projects are being done by junior miners or private equity-backed companies. These guys need to finance their projects off balance sheet, and reducing CapEx through flow sheet simplification is a huge check mark for them if they can find ways to do that. So I think it's not about discomfort with complexity. I think it's just about cost reduction.
That's a very important thing you're mentioning here. I really watch and read a lot of PowerPoint presentation and business plan from DLE companies, and everybody reduces CapEx, OpEx, and footprint. That's really the thing. Everybody does everything. But what's important, and I would honestly agree that probably everyone does it. The question is, where do you put the trigger? I mean, if you reduce the OpEx by 2%, it's not the same story if you reduce it by 70%. What you said here is very important, is that what the primarily benefit by simplifying the flow sheet is that you're really cutting the CapEx. Life is about choices. If you have to make choices between CapEx and OpEx, you can take lots of moving pieces to bring your OpEx down. What you're saying is that you're doing the opposite. You're saying, okay, you cut the CapEx and you might be also reducing the OpEx, but the priority is on CapEx. Do I get that right?
When we first started, our emphasis in the market and all of our unit economics estimates and the way we were communicating with customers was very OpEx focused. And the reason for that is we think that in most projects, there's significant OpEx reduction potential because we are not using thermal-based processes or electricity-based processes. Put an OpEx calculation to your electricity or heat and offset that with our process, and you can see high potential for OpEx savings.
It's depending where you are. I mean, if you're in Saudi Arabia,
Exactly.
energy comes for free, heat comes for free.
Exactly.
Water is costly. And so all of a sudden your OpEx is flipping on its head.
And that's why I said for many, there's been some projects in the Americas where we've looked at and it's, hey, we're setting up this DLE plant. We basically have our own power plant. Our electricity is 20% of the local industrial price. In that case, OpEx is much more not flipped, but much more aligned. Oftentimes in early discussions emphasizing OpEx, I think we were overlooking this CapEx factor, especially when you look at who are trying to develop projects, when you look at where interest rates are, they're not going down anytime fast, I would guess. And so I think you really can look at CapEx as a major driver for a lot of these customers.
Which is, again, a very interesting segue to how do you deploy? What are your projects where you're working on and what is in the pipe for you for the coming year?
I'll start with where Altillion is as a business today. We are a pilot stage technology company. We have 2 pilot plants here in Houston in our facility, and our customers ship us their brines for us to process in our pilot facility.
What's the size of your pilots today?
We have 1 pilot that processes brine at 12 liters per minute, or around 3 gallons per minute. Because of dynamics in the market, we actually built a second pilot unit that is 12 liters per hour instead of 12 liters per minute. We found that as we transition to the post DLE processing with our system, our larger pilot was oversized for many of the field pilots that our customers and our technology partners were running. So we built a smaller unit to match what size those pilots were at.
You're the first one ever, which I hear downscaling the pilot unit. Usually it goes the other way around. It's interesting.
I know. Yeah. It was an interesting dynamic for us, but it's been great. Now we have 2 pilot sizes, 3 gallons per minute, 3 gallons per hour. And so customers are shipping us in brines. We have our own full on-site wet lab with analytical. And so we're running all of our own analysis in addition to third party. And so for us, next stage of the business is really taking our technology to the field to operate live continuously at a customer location. We would consider that TRL or technology readiness level 7 out of 9. On-site operation of the technology in the field. That's what's next for us. We're aiming to do that in 2025.
The partnership with Evolve, it talks about a project, but didn't mention the project. Is it because you're looking for the project, you're looking for the place, or did I misunderstand it?
The start of the collaboration will be Evolve installing some of their technology in our pilot facility here in Houston. We have a number of customers to run potential testing on those technologies. It really touches on that spirit of collaboration I mentioned that I kind of take with industry. Our pilot facility was designed for us to take third-party technologies and integrate them at various steps of the process. We want technology collaborators to come and do that. Evolve is not the first. We've had others that haven't been publicly announced come and install technology, run tests in our facility, and we expect to have more following Evolve this year. There's a lot of very careful planning and execution and proprietary information protecting that we're very used to doing because we're kind of serial technology collaborators. But yeah, it will start here in our pilot facility in Houston with customers sending brine.
I have a little brain, so sometimes I need to do analogies for me to understand. If I get you right, what you're doing here with the integration and the potential testing of other DLEs as a first treatment to your own process, Sounds to me like what Saltworks is doing with their DLE lab. So would Saltworks be kind of a competitor to you?
So first, I would say you definitely don't have a small brain. I've listened to many of your podcasts. You're definitely pretty high on the water IQ spectrum. I think it is probably fair to say that Saltworks is a competitor to Altillion. Saltworks is an example of a company where, because of how broad they impact the flow sheet, where they're placing their technologies, the way they're doing their kind of DLE lab type work, there's pieces of what they do that could be very valuable around what we're doing, but there's also very clearly major sections of the equipment that they're aiming to provide that we're aiming to provide an alternative for. I'm very public and open about the fact that Altillion's process is not osmosis, OARO, thermal evaporation, no dedicated boron removal step, but you'll always see me harping on, we're not doing dewatering. We're not doing high energy dewatering. We're not doing membrane dewatering. And so I think companies that are doing that could probably naturally see us as competing.
Saltworks is my not so distant neighbor. I have another not so distant neighbor with whom you're working, I believe, which is
Telescope Innovations. Yeah.
Telescope Innovations. So what's the status of that project, and will it take you to Vancouver anytime soon?
I hope it will take me to Vancouver sometime soon. It'd be excellent if that was in the winter months. Our collaboration with Telescope Innovations has been excellent. They're a really great crew. And really the work that they're doing around the carbonation process, the conversion process, right, to take concentrated lithium chloride as an example and convert that to carbonate, battery grade carbonate, is really interesting. We've worked closely with them on the output of our pilot plant for multiple customer brines where we've generated a highly concentrated lithium chloride in the order of 35,000 plus milligram per liter lithium concentration. We provide these concentrates to Telescope, and they've repeatedly successfully converted that to battery grade lithium carbonate. And so, yeah, I've definitely a very high regard for those guys. And that collaboration continues on both battery grade carbonate conversion, but we're also exploring some other areas of test work together.
I get your point about keeping doors open and trying to really be collaborative with everybody in the sector. But if I take you full circle to Xedia's 2017 soft pivot, where you went from kind of that philosophy to being really specialized around the vertical in the Permian Basin, wouldn't it be in your interest today to say, okay, we can be working with any kind of brines, and obviously not just with lithium, we could be doing other minerals, but let us be the absolute specialist of the Salton Sea. Probably the Salton Sea would be a terrible choice. But picking a vertical and region of very specific subsets of spent brines or produced water brines, or I get your point about the economics of that, but just in terms of positioning yourself in the market as the dominant player for that specific niche, would that make sense for you today?
I talk about lithium brine flow sheets or DLE flow sheets from beginning to end as this funnel of variability. When you start at the front end, the funnel of lithium brines is a very, very wide opening, right? The variability of lithium brines is extremely high. As you work across the flow sheet, that funnel of variability starts to narrow. In terms of the variability in process conditions or specifications of the brine, by the time you've hit the eluate of a DLE technologies are taking the brunt of this funnel of variability. They're really taking very broad ranges of sodium, calcium, magnesium, other heavy metals, all kinds of things. And it's their job to act as that first stage limiting factor to drive the variability down. By the time you get to the eluate is no longer even that original brine. The eluate is fresh water that's rinsed, the lithium, eluted the lithium from an absorbent, or it's an acid that eluted the lithium from an ion exchange. And you're talking about a totally new aqueous fluid. And the eluate variability across many DLEs is much more narrow. And in many cases, we're very indifferent to what that original brine source was. Once you get to the eluate, your ratios will be a little bit different. The carryover of sodium, carryover of divalence, different things will vary. Lithium concentrations will widely vary, but for the most part, that variability doesn't impact the way we would feed that to our system. And so for us, it truly does at that DLE eluate point start to become a little bit irrelevant what the starting brine actually was.
You mentioned how rolling out to a pilot site this year would make you TRL 7. What's your horizon for being commercial? When do you intend to be commercial?
These are always delicate timeline discussions, right?
Speculative, and I do know that it's always wrong, but it gives us an idea.
Yeah, totally. I can say that we are in discussion with customers where we expect to be in construction of our first small commercial systems sometime next year, in the back half of next year. Now, from a scale perspective, when I say small systems, these are systems that would be onshore US. We're very comfortable executing. We have to get to the field. We have a number of things to prove continuously. We've been through the process tech scale up rodeo. We know what we're going to run into in terms of things to overcome and engineering inputs. We are quite comfortable with the kinds of system sizes that we're contemplating for kind of back end of next year. A lot of that will depend on do those kind of customer projects really move ahead. But I would say 2027 for being true commercially ready for us is very feasible.
What needs to happen on that path towards the second half of this year for the small scale commercial and then 2027 for the full scale commercial? Do you need to raise money? Do you need to fund new partnerships? Do you need to have a very specific industry shareholder, which then also gives you a playground? What would be an ideal scenario for you?
I think you've hit many of the things that would help. Capital for sure will be required. We'll need capital for expanding these field systems and getting into the field. There's definitely some team additions that we're looking to add throughout this year, both on the engineering and execution side of the business, but also on the technical side. A lot of what we do touches kind of hydrometallurgy, and we're going to add some additional hydromet expertise to the team we already have. But I think beyond capital and team partners is so critical. It's easy to get bogged down in testing and going out and running on sites that don't have pathway to commercial project. As an early stage company, you definitely have to be able to focus your resource in on what is the pathway to that commercialization. And so even for these fieldings this year, it's important that we're fielding with partners and customers that truly have a pathway to, okay, what's after this? What's this next iteration look like? What does commercial implementation look like?
So that means you're actively looking for partners, actively fundraising, actively hiring people. If you have to prioritize one of the three, it's partnerships.
I would say if I had to prioritize one of the three, right now is partnerships.
So we have your path to the end of the year, your path to 2027. Where are you in 2030?
Oh man, in 2030, I think you'll see our concentration purification process installed and operating in numerous plants. And for what I expect will be 1 or 2 years already at that time. Solvent extraction came on hot and heavy early in the DLE discussion because solvent extraction is an inherent part of mining and metals. I think it's cooled off a bit because of some of the environmental concerns and some of the cost concerns, especially in this low price environment where everyone's looking for cost reduction. Liquid extraction is circling the discussions much more strongly again. And I think it's because of what liquid extraction offers. And I don't see a pathway today for another company to implement liquid extraction at the level of cost efficiency that we can. We're talking about taking what traditional solvent extraction would need for 5, 6, 7 stages, minutes of residence time per stage. We're doing in 2 stages with seconds of residence time per stage. Just the amount of chemistry we use goes way down. The amount of equipment goes way down. I think liquid extraction will be an integral part of these facilities by 2030. I think we have a really good shot at being a big part of that.
Thanks a lot for what you shared in the deep dive. If that's fine for you, I propose you to switch to the rapid fire questions.
It's time for the rapid fire questions.
What is the toughest challenge for a Watertech startup?
I will mirror what some of your other podcast guests have said, and I will say people.
What would be your best single piece of advice for the founders and managers of the about 1,000 early-stage water startups?
Data is everything.
What's the knowledge you wish more investors knew about the water sector?
Highly underappreciated, but also data is everything.
There's a pattern here. What was your most unexpected partnership and what did it bring you?
I would say local vendors for very simple things like marketing materials, website graphics, PR, those kinds of things. It's been really helpful to go local and find people that want to stick into sort of your stage of your business.
Super short, profitability or growth?
Profitability.
What's the next profile you'll hire? You named some, but what would be the number one you'd hire?
Number one next hire will be Hydromet.
If someone listening to this says, oh, that's me, they can reach out to you, you're actively hiring.
They can reach out to me, actively hiring. Shortly after that, we'll be looking at another good process engineer.
When you hire, that person now needs to see if they are a right fit, sector experience or startup experience.
Sector.
Do you want to open new markets or double down on the current ones?
I would say double down on current ones, which includes some other battery and electrification metals in addition to lithium.
Okay, so you're cheating. You're saying you double down on one, but you enlarge that one. So okay.
Double down on lithium primarily.
What's that tool nobody speaks about, but you couldn't live without?
Evernote.
What's the single piece of insights your ideal customer profile needs to hear right now?
We're ready to get to the field, and we think we have a pathway to massively lower cost.
When you say ready to go to the field, how fast can you be in the field?
I'd say from today, we need 3 to 4 months lead time.
What are you desperately needing and want to raise an open call for right now? And I know that when I say desperate, usually people see it as a negative, but see it as a positive desperate.
I would say more full flow sheet collaboration, maybe from end-to-end engineering and full flow sheet collaboration to really drive cost optimization around not just the straight linear flow sheet, but all the inputs and outputs around that linear flow sheet.
What can and should I do for you?
I'm already highly appreciative of this discussion. This has been great. Keep us in mind as you talk to other technology companies. Always remember that we're collaborators before competitors, and we'd love to work with everyone.
Sounds like something I can do. If people want to follow up with you, where shall I redirect them the best?
You can redirect them to me on LinkedIn, Jay Keener. My email address, j.keener@altillion.com. We're here in Houston, Texas. We love hosting visitors and showing them what we're doing so they can give me a shout and stop by.
Well, as always, if you're listening to that, check the description. The links will be down there. I might be in Houston later this year. I will remember.
Please do.
Thanks for everything you shared today and talk to you soon.
Thanks so much for having me.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.